Today we're reviewing over these sections. Everything that you're going to see in today's test review will be on your test tomorrow. So if there's something you don't understand, either ask for clarification now, or you need to make sure you're studying it tonight while you're preparing for the test. In the first section on your test tomorrow, it's going to be to identify the domain and range of the relation. So go ahead and identify those and then tell me whether or not it's a function. Is the relation a function? All right, so say with me. Domain, 0, 2, 3, 5. Okay, and just so happened that's the order it was written in, but if it's out of order in the relation, make sure when you list it, it's listed least to greatest. All right, and then what about the range?
1, 4, 7.
Okay, 1, 4, and 7. You do not need to repeat the 4. Okay, so if it repeats in the relation or in the tables on your test, make sure you don't repeat when you're listing it. So yes, those are my range values. Is it a function?
No. Yes.
Yes, it is. Because even though I have a repeated range value, that's not the value that I go by to determine if it's a function. If my input values have only one output for each individual input, then it is a function. So even though 2 and 5 both had outputs of 4, because they are different input values, it's still a function. All right? I know that's kind of tricky, but that's just the rule. Okay, next example. All right, tell whether the ordered pairs is the solution of the equation. So you're using the values for the ordered pair, plugging them in to the equation, and simplifying both sides of the equation. Go ahead and try that. At least on the first one. We'll check the first one and then do the second one. All right, so when we plug in the values, we plug in 0 for x, we plug in 4 for y. We're going to test these solutions. All right, so 0 for x, well, that's 0, right? 3 times 0 is 0, right? Yeah. 2 times 4 is 8. Does 8 equal negative 8? No. No. Line through the equal sign, it's no. Just make it obvious that your answer is no. Okay, if you forget the line through the equal sign, I don't really care. As long as it's obvious that your answer is no. If you say, whoops, I didn't mean to hit that button, but if you say 8 equals negative 8, if that's your answer on your test, am I going to mark it right?
No.
No, because you're telling me that they equal when they clearly don't. So you need the word no or the line through the equal sign, one or the other. All right, now in the next one, it's very important that you pay attention to the signs. This is one area that you could definitely make a mistake on your test. Do you subtract first? Or do you multiply first?
Multiply.
You multiply first. What's negative 2 times negative 7?
14.
Positive 14. Negative 6 plus 14 now is 8. 8 equals 8. So a check mark or a yes, okay, something along those lines. Make it obvious that you realize that both sides equal. All right, now in the next example, we're writing the equation in function form. Okay, I am going to take it one step further and go ahead and set up your input-output tables just because it doesn't take very much time at all. But here we're focusing only on writing the equation in function form. So what do we solve for? We solve for which variable? Do we solve for x or do we solve for y? We're solving for y. Do we care if there's a number attached to the x? No. Leave it. Leave it attached to the x. We don't care. Do we care if there's a number attached to the y? Yes. There cannot be a number attached to y unless it's my understood one. Okay? So go ahead and write these equations in function form with that knowledge. Okay, so we are going to, like we just said, we want to solve for y, so we need to get every other term on that side of the equation to the other side. So how do I get rid of 2x? Subtract it from both sides. So now I have y equals, and which term do I write first? The 1 or the negative 2x? Negative 2x. The x term comes first, then the number by itself. Now it's in function form. Done. All right, are you done with the second one?
Yes, ma'am.
Okay, so what do you do first on the second one? Subtract x. Now here's where it can get kind of tricky. There's no number attached to the x, so it kind of starts messing with our head a little bit. But it's still the same process. Negative 3y equals which term comes first? Negative x minus 9. Now don't let your negatives mess you up either. What do you divide everything by? Negative 3. Everything by negative 3. So what's negative 1x divided by negative 3? Positive 1/3 x. And the way I want you to write this, now if you write x in your numerator, I'm not going to count off on this test, but I do want you to start getting in the habit of writing the x next to the fraction, not in the numerator. 1/3 x positive, and then is it plus or minus 3? Plus 3. Negative 9 divided by negative 3 is a positive 3. So our signs are very important here. I need to box in the whole thing. All right, our signs are very important here to make sure that we get them correct. Because if you say minus 3, then your whole thing is off. All right, everything is off. Now, I want you to go ahead and set up your input-output tables. Actually, let me just erase this box in. All right, let's set up our input-output tables now, our x and our y, for each one of these equations now. So the one on the left goes with our first equation, the one on the right goes with our second equation. What's the domain I used for the first one? What's my domain? Yeah, very good. I just used my standard domain set because it's a whole number attached to my x. All right, so negative 2, negative 1, 0, 1, and 2. I plug in my numbers, and my outputs are 5, 3, 1, negative 1, negative 3. Who got that right? Okay, so then we're going to take that and graph it. I'll show you that in a minute. What about our domain for the second equation?
Negative 6, negative 3, 0, 3, 6.
Why did she use multiples of 3? Because of the denominator. My denominator tells me what multiples to use. Did you get those outputs?
Yes.
Okay, and then we would take them and graph them, which we'll do shortly. All right, now let's find intercepts. Now, you need to pay attention to the directions, both on your quiz for those of you who still need to take it, and then on your test tomorrow. Find the intercepts. There is your clue on how you're going to set up your graph and how you're going to solve. If you're finding intercepts, let's say I'm solving for x, what do I substitute for y? 0. If I'm solving for y, what do I substitute for x? 0. So I substitute 0 for the variable that I'm not solving for, and then I graph it. All right, go ahead and find each one of these intercepts. Okay, so if I'm finding my intercepts, I'm going to substitute 0 for the variable I'm not solving for. So on the first one, I'm solving for x, I substitute 0 for y. That cancels out that entire term. 2 times 0 is 0. Now, 3x equals 6. What do I divide both sides by? 3. X equals 2. On the other equation, I substitute 0 for x because I'm solving for y. What do I divide both sides by? Negative 2. Y equals negative 3. So here's how I graph it. I had many students on the quiz Friday put these together as one ordered pair, and they graphed it over 2, down 3, and they plotted their point here, and that's all they had. Okay? But remember, these two intercepts stand for the points that lie on that axis, an x value of 2 and a y value of negative 3. If you want to see it as an ordered pair, you can write it as an ordered pair, but you are not required to. So on the first one, our ordered pair would be 2, 0. On the second one, our ordered pair would be what? 0, negative 3. Do you have to write your ordered pairs? No. You can just recognize that a point goes on an x value of 2 and a point goes on a y value of negative 3. Plot your points. Do you see the arrows on either end of the line? The arrows are important. What do the arrows tell your reader? That the line keeps going on into infinity, that these are not the only solutions to this equation. The arrows are important. What happens if you don't put your arrows on your test? You lose points. you lose points, okay? They are important. They mean something. It's not just because I want to make my line look different, okay? They are important. All right, so I want to do it one more time. Find the intercepts of this equation, and then I want you to visualize the graph, or maybe just sketch it really quick on your paper. We're not going to formally do one on graph paper, but just make sure that you know where these points are going to go on the graph. Okay, so we start with our substitutions. 4x plus 3 times 0 equals 12. 4x equals 12. Divide both sides by 4. X equals 3. Did y'all get x equals 3?
Yes.
Okay, and then for y, I substitute 0 for x. Divide both sides by 3. Y equals 4. Did you get 4?
Yes.
Now, can you make these into ordered pairs?
Yes.
Yeah, what would this ordered pair be on the first one?
3, 0.
3, 0. What would the ordered pair be on the second one?
0,
0, 4. If that helps you visualize the graph better, do it. Okay? So x value of 3 and a y value of positive 4. And do we just connect the points like this?
No.
Okay? The line has to go all the way through, arrows on both ends. All right, so that's how we graph using intercepts. Now I want to talk about the slope of the line. Find the slope. We're not even going to solve this last one. We're just going to do the first two. Yeah, the last one is kind of weird. Now on the first two, okay, I've got to use the formula. I've got to use the formula. Anybody remember the formula? All right, tell me. Yep. Very good. It's y2 minus y1 over x2 minus x1. All right, my first number is what? x1, then y1, x2, then y2. That's how I label them. I want you to go ahead and find the slope of both of them. All right, here's my formula. I'm going to write it down up here. Am I going to write you your formula on your test tomorrow? No, you have to know it. Okay? All right, so here we go. 7 minus 2. Did you put that on top? Over 4 minus 1. 5 over 3. Wait, do I change it to a mixed number? No, leave it improper. Now, if I can reduce it, reduce it. All right, now on the second one, did you catch the double negative? Okay, what happens to a double negative? Change to a positive. Negative 4 over positive 8 now. Can I reduce it? Yes, I can reduce. That's different than changing to a mixed number. Reducing just means to simplify to negative 1/2. All right, like I said, we won't do the third one. All right, that you won't have one like that on your test. Any questions? All right, now I want you to see full circle what we were doing at the beginning of the lesson, writing an equation in function form. I want to do one more. Write it in function form and make your table. Okay, and then I'm going to show you what it will look like on the graph. You don't actually have to graph it. You can do a quick sketch if you want, but you don't have to. Write it in function form. Come on. Write it in function form and then make your table. Now, let me be clear. Do the directions say anything about a table? I will not tell you on your test tomorrow that you're making a table. How do you know? Does it say anything about intercepts? So how else do you graph a function? You make an input-output table. You make an XY table. So you've just got to know. If it tells you to graph the equation, you have to have ordered pairs. You've got to come up with a table. Okay, so let's, sorry, let me go over to this other slide. All right, so to write it in function form, what do I do first? What do I do first to write it in function form? All right, very good. Man, where's my, no, that's intercepts. Where's my graph? Okay, I'm just going to redo it. Okay, subtract x from both sides. All right, and I get 2y equals negative x plus 6. Is that how y'all did it? Divide everything by 2. Y equals negative 1/2 x plus 3. Are you done with your table?
Yes, ma'am.
What numbers did you put in your table?
Negative 4, negative 2, 0, 2, 4.
Very good. Why did you use multiples of 2? Yes, it's your denominator. All right, so I use my XY values. Okay, so -4, -2, 0, 2, 4. All right, what's my Y values? 5, 4, 3, 2, 1. So here's how it's going to look on the graph. All right, I'm going to go left 4, up 5, left 2, up 4, 0, 3, 1, what was it? Or 2. Sorry, let me go back over here. 2, 2. 2, 2. And 4, 1. All right, and what should it always form? A straight line. And remember, the arrows go through both points, and we're good to go. All right, so that's how you're going to graph the equation. You have 2 of those on your test tomorrow. Make sure it's in function form, and then make your tables. If you understand that, that's everything you need to know for your test tomorrow.